Hello and welcome. Sorry, I somehow clicked and moved aside. All right, so today we're going to be looking at lesson 1.1. It is our first lesson in our ecology unit, okay, and this is going to be covering food webs and energy flow. All right, so a food web demonstrates the flow of energy that occurs in an ecosystem. We use arrows to show what an organism or where an organism's energy is transferred. So the arrow is pointing towards the mouth of the predator. If you look at, let's see our diagram here, let's look between the grains and the birds. Okay, it's saying that the energy from the grains is going into the birds. Okay, it's not pointing at what it's eating, because otherwise it'd be telling us that the grains are eating the birds, and that doesn't make any sense. Okay, so the arrow points in the direction the energy is flowing. All right, so pause a minute, see if you can answer practice question number 1. How is a food web different from a food chain? Okay, we have our image here of a food chain and our image of a food web. All right, so back to food webs. Autotrophs, okay, are also known as producers. Auto means self, troph refers to eating, like pigs eat out of a trough, okay? These are plants, okay, because plants make their own food through that process of photosynthesis. So they are autotrophs, or they produce their own food. Heterotrophs, hetero means different, troph again means food. So this means that they have to go to a different source for their food. So we call these guys consumers. Okay, they have to eat other things for food. Then we have our decomposers that break down matter back into nutrients and minerals to be reused. Okay, make sure you know our two main decomposers. That's going to be bacteria and fungi. Fungi are going to be like mushrooms, mold, and yeast. Okay. All right, in this food web, energy from the producers transferred or consumed by the primary consumers, okay? So we've got our producers, which are the corn, the flowering plant, and the lavenders. Let's see if I can move this a little bit up this way, okay? And so that energy is being transferred to my primary consumers. Primary consumer means first level of eater. Okay, so that's going to be my grasshopper, my butterfly, and my fruit fly. Okay, my secondary consumers are my second level of eaters. That means that these guys are eating my primary consumers or my producers down here. So that's going to include the rat, the frog, the dragonfly, and the thrush. Okay, and then tertiary refers to 3. So this is my third level of consumers. These just also happen to be the top predators in this food web. That's going to be the python, the wolf, and the eagle. Okay. There we go. All right, let's play this video. See if... I hope this works.
Let's look at what happens when an So last time we put a polar bear in the desert, and I still feel bad about that. The good news is that in real life, a polar bear probably won't just wander into the Sahara, but when an ecosystem gets out of balance. Last week, we learned that a habitat is home to a tangle of food chains called food webs. The animals depend on each other for food, but they don't just need each other. They rely on the non-living things in the habitat too. This interaction of living and non-living things in a habitat is called an ecosystem. The things in an ecosystem are all connected. Just like when you touch one part of a spider web and the whole thing vibrates, when one link in the food web is threatened, it can shake up the whole ecosystem. Let's see what might happen, for example, if an ecosystem loses a species. Since we're talking about food webs, I think we should look at spider monkeys. They're called spider monkeys because they hang upside down from their tails with their arms and legs dangling. This is somehow completely adorable. These primates live in a tropical rainforest habitat, which is just bursting with some of the coolest creatures out there. Toucans, jaguars, sloths. As we learned last time, these animals need each other to survive. And spider monkeys happen to play a particularly important role in the rainforest food web. They eat mostly fruit, which contains seeds, and we know that seeds are how plants make more plants. When a spider monkey snacks on a berry, he gets to enjoy the tasty fruit while also doing the plant a solid favor. When the monkey moves on to another part of the forest and passes the fruit, he leaves the seeds behind. Wait a while and then voila, you have a new plant. Imagine thousands of monkeys eating thousands of fruits every day. More monkeys equals more plants and trees. Those trees support lots of other animals. Insects and sloths eat those plants too. And more spider monkeys, insects, and sloths mean more food for carnivores. Leopards dine on the sloths and spider monkeys, while frogs eat the insects. And of course, our decomposers, like fungi and bacteria, break down leftover plant and animal matter. So we're talking around 50,000 plant and animal species that rely on these plants. Now imagine the spider monkey population starts to decline. Maybe they're hit with a strange new disease, or maybe humans overhunt them. If the monkeys aren't around to eat the fruit, then the seeds aren't scattered around, and the forest stops growing, leaving fewer fruits for fewer monkeys. Not only that, fewer plants means less food for other animals, like insects and our sloth friends. That means the insect and sloth numbers start to decline, and that means less food for the animals that eat them. All of a sudden, none of the animals in our ecosystem have enough to eat, all because of the loss of one species. Do you see how this could get really bad? Remove one piece of the food web and you might knock down the whole thing. That's bad news for us, too. The good news is that ecosystems want to be in balance. After a natural disaster like a forest fire or a flood, things might be wacky for a while, but habitats can usually get back to normal. But if things get really bad, the habitat might change forever. The old species will leave, searching for a better place to live. New species will come in. Life will keep going, but it won't look the same.
All right. So looking at how
happens when an ecosystem.
Oh, next page. There we go. So looking at what happens when we remove a species out of a food web. So here's your practice question number 2. You have this diagram in your notes. I want you to try to answer this on your own. Give me at least 2 potential effects of removing the rabbits from this food web. Okay, our rabbit is right here. Okay, so pick 2 other species and tell me how they will be affected. Okay. All right, last thing we're going to be looking at are energy pyramids. So an energy pyramid is another way to represent the energy transfer in an ecosystem. Okay, levels of the pyramid are divided into trophic levels. So our first level always starts at the bottom. Okay, it's our producers. Second level is our primary consumers. Third level, secondary consumers. Tertiary consumers at the top. Now, we do notice that our producers, okay, if we're looking at the mass of this, our producers have more organisms down here. And as we move up, we're going to have less organisms at the top. That makes sense, seeing as how, you have to eat more, okay, to get all the energy you need. So we need more producers to feed all these guys up top. So you need to be familiar with something called the 10% rule. It says only 10% of the energy in one level is transferred to the next. The other 90% is lost to the environment as heat during metabolic processes. That means that producers start with 100% of the sun's energy, okay, because they're getting that energy directly from the sunlight. So they have 100% energy. But when my primary consumers come along and eat them, they only get 10% of the sun's energy. My secondary consumers are going to get 1%, and my tertiary consumers are going to get 0.1%. So it decreases by, actually, I don't know, that might not be the right math term, but we're only passing along 10% of each level each time we go, okay? Is that it? Oh, I guess this is a short slide then. So that concludes our food webs and energy flow. Head back to Canvas. Make sure you start working on those must-dos for lesson 1.1. All right, see you next time.